looking to do a quick review of how to solve equations. We have a simple starter equation, x minus 7 equals 11. I've drawn a vertical line through my equal sign to help me see the left versus the right side. If you're subtracting 7, you want to do the opposite of subtracting, which would be adding. And I have that vertical line, so I make sure I do it once to the left and once to the right. The reason I add 7 is a minus 7 and a plus 7 add to 0, leaving just that x over there. Equal sign travels down that vertical line, and on the right side we have 11 plus 7, which is 18. So the solution to this would be x equals 18. A little bit different, but on the same track. We're dealing with a one-step equation. We have 2 times x, important to remember, there's a times there, equals 4, vertical line if it helps you. Always look to see what is the opposite of the operation. Opposite of multiply is divide, and then you want to divide by the exact same number as is being multiplied. So 2 times x, I want to divide by 2. Once to each side, or rather with division and multiplication, it should be done to every term. So this side is divided by 2, those cancel. Over here, I should say the x gets carried down. Over here, 4 divided by 2 is 2. Now going to a little bit trickier, we're going to go to a two-step equation. And we reviewed in class that when we have a two-step equation, we want to make sure and do the opposite of PEMDAS, which means we want to do SAD MEP. We want to do our addition and subtraction first, then our division and multiplication, then our exponents, then our parentheses. In this case, we want to look at our, here for our addition. I'll draw my vertical line so I can see left and right. I want to take care of the addition. Opposite of adding 4 is subtracting 4. Once to each side, those become 0, leaving us that 7x is still here. Over here, 53 minus 4 is 49. Now I still don't have that x isolated. I have 7 times x equals 49. Opposite of multiplying by 7 is divide by 7. Once to each term, 7's divide, leaving the x over there. 49 over 7 is 7. Sometimes you might see where you have a variable showing up on both sides. For example, I see the x here and the x here. When you do have that situation, look for the smaller of the two. 3x, 7x, 3x is the smaller. You might also just want to look and kind of see which is going to put you in the best situation. In this case, I want to subtract 3x from both sides. See that I've done it once on the left side, that vertical line will help me, once on the right side. Only the like terms can be combined, so these can be combined to 0. These can be combined. 7x minus 3x is 4x. That minus 8 is different, it's not similar, so it cannot be combined. And on the left side, I still have that 4. Just got carried down. So I have 4 equals 4x minus 8. Now that I have all of my x's on the right side, I want to move all of the other values over to the left. So I'm going to do that by getting rid of this minus 8. To get rid of minus 8, I'm going to want to do the opposite of subtracting 8, which would be adding 8. Those make 0. 4 and 8 make 12. 4x on the right. Okay, one last step. 4 times x. Opposite of times 4 is divide by 4. Those cancel out. X, 12 over 4 is 3. So we've done a quick review of solving equations. All right, let's review graphing an equation from the slope-intercept form. So I have my graph here with my x-axis labeled and my y-axis labeled. And I have two equations, nicely color-coded. This top one's going to be in blue. First thing when we're graphing is we want to identify our y-intercept. Y-intercept is going to be in the equation, the number that is not attached to the x. See how this one is attached to the x, whereas this one is separate? That's your y-intercept. So the y-intercept for this equation would be +3. Okay, so that's our b. We're trying to match it to the formula y equals mx plus b. So that right there, that 3 is our b. So that means I'm going to go to my y-axis. I'm going to find the 3 and make my very first dot right there at the 3. Now I'm going to go to my slope. The slope is the number attached to the x. So in this case, right there, that would be my m. In this case, it's in a fraction form. That's convenient. The top number of the fraction is going to give you your up or down and by how many. If it's negative, you go down. If it's positive, you go up. In this case, it's -3/4. So the -3 means I'm going to go down 3. So I'm going to start at that 3 we put there. 1, 2, 3. The bottom or the denominator of the fraction is going to tell you to the right, always to the right. So in this case, it's a 4. So I'd go 1, 2, 3, 4. And make my second dot. Once I have 2 dots, I'm going to grab my straight edge. I'm going to put it through those 2 lines as best I can. And draw my line. So I've now graphed the blue one. Let's look at graphing that pink one. Grab my pink highlighter. So looking at this one, oops, not part of the graph. Y equals 2x minus 3. Same thing, I'm trying to match it to this form. So the plus b, or the part that's not attached to the x, that is your y-intercept. In this case, it's that -3 right there. That's my b. So I'm going to go to my y-axis. I'm going to find -3 on the y-axis and start by placing my first dot there. Now I'm going to look at my slope. Again, the slope should be the number that is attached to the x, sitting right in front of it, and that's the 2 in this case. That's my m. Now in this case I had a fraction. This one's not a fraction. If it's not a fraction, you make it a fraction by putting a 1 underneath. 2 divided by 1 is still 2. I haven't changed the number, but I've given myself a fraction. Top number gives you up and down, and by how many? If it's positive, up, negative, down. This is a positive 2, so I'm going to start on my y-intercept. 1, 2. Bottom number is 1, always to the right with the bottom number. 1 to the right, second dot. Grab my handy dandy ruler. Line them up. And go ahead and connect the dots. So we've reviewed graphing lines when they're already in slope-intercept form.
Yeah. Function is an x equals 1y. Okay. Yeah. Student, there's no need to feel down. I said student, pick yourself off the ground. I said student, cause you're in a new unit. There's no need to be unhappy. Yeah, student, there's some things you should know. I said student, when your grades are real low, you can sing this in. I'm sure you will find many things will come to your mind. A function is an x equals 1y. A function is an x equals 1y. They have every x with only one y. You can remember if you try. Yeah, a function is an x equals 1y. A function is an x equals 1y. You can get yourself an A, you can have a good year, you can give your parents a thrill. Domain input, x values you have have. I said domain input, X values you have. I said domain input, X values you have. But you got to know this one thing. Range output, Y values you find. I said range output, Y values you find. Range output, Y values you find. I'm sure you can get this today. Yeah, a function is an X equals 1Y. A function is an X equals 1Y. They have every X with only one Y. You can remember if you try. Yeah, a function is an X equals 1Y. A function is an X equals 1Y. You can get yourself an A, you can have a good year, you can give your parents a thrill. A function is an X equals 1Y. A function is an X equals 1Y. Domain input, X values you have, and range output, Y values you find. A function is an X equals 1Y. A function is an X equals 1Y. Domain input, X values you have, and range output, Y values you find.
So we're going to review how to figure out if a relation is a function. So a relation is a mapping of inputs to outputs. I put in a number, I get out a number. Some of them are functions, and functions have one input gives you one output. There can't be any crossovers. So first we're going to look at how would you determine if they are graphs. So I have a graph here. See the blue line. Easiest way to do this with a graph is to do the vertical line test. So I'm going to take my ruler and you're going to create a vertical line. And if you want, you can just do it with a ruler without tracing anything. And you're looking for how many times the ruler intersects the graph. So here obviously 0. Keep moving it. I just go left to right. So start moving it until I intersect. And if you need to, go ahead and draw that vertical line. And you can see that it intersects one time. And you're going to keep doing that. You're looking for any point on the graph where you intersect more than once. Still just one time right there. And still just that one time right there. And as you can see, no matter where I take this vertical line across this graph, it only intersects one time. That means it passed, so it is a function. So trying it with this over here, just have a second graph drawn there. And you can see it kind of looks like a oval. I tried to draw an oval there. And I'm going to do the same thing. I'm going to take my ruler, create a vertical line. You can see right here with my vertical line, it intersects one time. But the second I move over to the right, draw my vertical line, how many times does it intersect? 1, 2 times it intersects the graph. If it ever does that, ever crosses more than one time, there could be some where they cross 3 times. In this case, it crosses 2, and therefore it fails, and that means it's not a function. You can see it's actually going to fail quite a few times. Only right there on the ends where it's going to have just one value. Okay, so that's if it's a graph, how we would see if it's a function if we were given the graph. Now there's other ways that we might be shown the information for a relation. So here I have, what if you were shown them in a t-table? So a t-table, you're going to have an x column, your inputs, y column, your outputs. T-tables, the way to determine if it is a function or not, you're going to look at your inputs and you're looking for any repeats. So 5, compare it down, there's another 5 right there. So if there is ever a repeat in the input column, only the input column, then it fails. Not a function. Now we've got just a second example. So again, you're looking down your x column. You're looking for any repeats. -2, nope, I never see it again. 0, never see it again. 2, never see it again. 1, never see it again. No repeats in the input. That means it passes, and it is a function. Now we also looked at arrow diagrams. Arrow diagrams, you should have two collections. The one on the left is your input, one on the right is your output. There should be arrows going from the inputs to the outputs. This one, you're going to count how many arrows come out of each input. So 10, see there's 1, 2 arrows coming out of 10. 20, there's 1 coming out of 20. 30, there's 1. 40, there's 2. If there are ever more than 1, then it breaks the function rule and it's not a function. Second example of an arrow diagram. Again, we're counting how many arrows come out of each input. 10 has 1 arrow coming out. 20 has 1. 30 has 1. And 40 has 1. So as long as all of the inputs have 1, no more than 1, arrow coming out, then it is a function. And last, we're going to look at what if you have a list of points. So a list of points there. So with this one, what I find is easiest is to go through and just circle your x values. They should be the first of each one of each coordinate pair. And you're looking for any repeats again. You see the zeros repeating, 2 and 3, but there is a repeat here, so it's not a function. Looking at our last example, again, I'm going to go through and circle my x's. Looking for any repeats, -2 only occurs one time, -3 only occurs one time, 2 only once, 3 only once. Therefore, that one is a function. So we've looked at 4 ways of seeing a relation, and we've seen examples of functions and not functions. I'm going to quickly review function notation. So this is how we write function notation. F of x is how you would read this. And it means that f is the function name, x is the input, and then you should have an equal sign and some sort of expression over on the right. So this would be read, f of x is equal to 7 times x plus 2. When we want to evaluate, that means we're going to plug a number in for x. We write f of, and then whatever number you want to plug in. Let's say it's 1. So this would be read, the f of 1 equals, and I'm just going to plug 1 in for x, and go ahead and get a number. That'd be 7 plus 2, which is 9. So you would write f of 1 equals 9. Second example, a little bit larger of a function, a little bit more complicated. This would be read, f of x is equal to x squared plus 2 times x plus 4. So again, the way that we do this, if we were going to evaluate this function, we'd write f of, and then whatever number we're going to evaluate it for. So maybe it's f of -3. We're going to plug -3 in for the x's. Careful with our negatives and squared. I'm going to put parentheses around the -3 plus 4. -3 squared means -3 times -3, which is 9. Plus, this is 2 times -3, which is -6. Still have that plus 4. So I have 9 minus 6 plus 4. 9 minus 6 is 3 plus 4 gives me 7. So this would be f of -3 equals 7. So a quick review of function notation and how to evaluate.